Hi, this is problem 17 from the AMC 12A. There are 24 different complex numbered z such that z to the 24 is equal to 1. For how many of these is z to the 6 a real number? Okay, so we're dealing with the 24 roots of 1, and let's make a picture and see how far we get with that. So let's try to draw out what the 24 roots of 1 look like. So by de Moivre's theorem, we know that the angles separating the 24 roots of 1 are separated by 15 degrees. So let's draw our standard unit circle. Let's draw the 45-degree lines to kind of help us with this. Okay, so the 24 roots of 1 are separated by 15 degrees. So all these points along the unit circle represent the 24 roots of 1. Okay, so now trying to look for how many of these are such that z to the 6 is a real number. So let's look at these roots and see how many of these are such that when we multiply the angle by 6, we end up at some multiple of 360 degrees. So the very first one, of course, is just the 0 angle, and the next one would be 60 degrees. 60 times 6 is 360. The next angle would be a multiple of 360, would be 120, followed by 180, and so on. So that gives us 6 values. So those are the values that land us on the positive real axis. Now for the negative real axis, we're looking for which values or which of the roots of 24, or which of the 24 roots of 1, are such that when you multiply it by 6, you end up at either 180 degrees or 180 degrees plus some multiple of 360. So the first one that satisfies that condition would be 30 degrees. So 30 degrees times 6 gets you to 180. Going to 180 plus 360, 90 degrees would satisfy that. And continuing, we find that these values shown with the boxes, when multiplied by 6, will get you to the negative real axis. And that seems to account for all the roots of 1, or the 24 roots of 1, that will get you to either the positive or the negative real axis upon multiplying the angle by 6. So I think that's a total count. That's 6 plus 6 is equal to 12 for choice D.